4-4, greatest common factor, GCF. Today, we're going to expand on what you did yesterday with prime factorization. Today, we're going to have two numbers in a list. Here we have 18 and 24, and you'll need to find the prime factorization for both numbers. So 18 can be broken into, and remember, we're looking for the lowest prime number that goes into both of these numbers. So we have 18 can be 1 and 18, 2 and 9, and 3 and 6. We will select 2 and 9. 2 is a prime number. 9 is not. 9 can be broken into, well, 3 and 3. So 18 is 2 times 3 times 3. So we will write 2 times 3 times 3 off for 18 up above. Now we will do the same thing for 24 from yesterday. Oops. Now we will do the same thing for 24. 24 can be broken into 2 and 12, just like yesterday. 12 becomes 2 and 6, and 6 becomes 2 and 3. So the prime factorization for 24 is 2 times 2 times 2 times 3. And the prime factorization is for 18 is 2 times 3 times 3. Now, yesterday, you would have rewritten both of these answers for 18 and 24, their prime factorization, in exponent form. We don't want that today. Today, because we're going to find the GCF, we need them in expanded form. And here's why. We are going to look for items they have in common, things that occur in both lists. So in 18 and 24, we have a pair of 2's that they have in common. So we will take that pair of 2's and we will write down that they have a pair of 2's in common by putting a 2 in this list. Do they have anything else in common? They have a pair of 3's in common. So the greatest common factor is the answer to the multiplication of the pairs of prime factors they have in common. So they have a pair of 2's in common and a pair of 3's in common. So we're going to take that 2 and that 3 that they have in common, multiply them together, and you find that the greatest common factor is 6. This is what your work should look like for finding the greatest common factor. I recognize there are other ways to do this, but this is the way that I want you to do it here today. Now we're going to have the same numbers, but now we have a whole bunch of variables and stuff like that, because that's really what this lesson is about, is knowing how to find the greatest common factor when we have variables. So you'll remember from yesterday, we're going to take the variable stuff off, and we're going to find the factor trees without them in the prime factorization, saving some time because they're the same numbers. From the examples before. So we're going to have 18a squared b squared c squared is broken down into 2 times 3 times 3. And now I need you to write the variables in expanded form. So we're going to have how many a's? 2 a's, 2 b's, and actually 3 c's, because I copied it incorrectly. The other number, 24a to the third power bc, is broken down into 2 times 2 times 2 times 3, and then we have 3 a's, a b, and a c. Now we're going to do the same thing we did on the previous board, but now we have the variables, so we're going to circle the things they have in common. For the numbers, you remember they had the 2 and the 3's in common. Now we're going to look for variables that they have in common. So what do these two numbers have in common for variables? They have a pair of a's in common. They have another pair of a's in common. They have a pair of A's, and they have two pairs of A's in common, so we write down both of them. They have a pair of B's in common, and they have a pair of C's in common. Now we will rewrite this in exponent form. 2 times 3 is 6, A squared BC. This is finding the greatest common factor for pairs of numbers with variables. We're going to use this. Yesterday, you learned how to do factor trees. Today, we expanded on that by adding two sets of numbers with variables that you have to find something called the greatest common factor. Tomorrow, we're going to expand on this even more, and we're actually going to use the greatest common factor to simplify some algebraic expressions. This last board is the most important thing you're going to do in this entire chapter. It's called factoring out. And down on the bottom right-hand corner, you'll read all you're doing is undoing the distributive property. This is the most useful thing you're going to use later in math, beyond algebra. So it's very important. So we have 8m minus 16 as our problem. We want to end up with a problem that looks like the distributive property to start with. So we need to think of what number goes into both 8m and 16. They both can be divided by 2. They both can be divided by 4. And they both can be divided by 8. Let's pick 8 because it's the biggest number. So now we're actually going to pick the biggest number. So now if I take 8 out of the 8m, if I do 8m divided by 8, what are we left with? 8m divided by 8 leaves us with m. It's a subtraction problem. It will remain so. And then we do the second number, 16, divided by the 8 that we're going to factor out, and that leaves us with 2. So we'll put 2 there. So 8m minus 16 by itself, when we go to undo the distributive property, turns into 8 times the quantity, m minus 2. And we can check to see if our work is correct by doing the distributive property. 8 times m is 8m. It is subtraction, and 8 times 2 is 16. So we can start with the distributive property, which we did at the beginning of chapter 3, and work towards a solution. The beginning of chapter 3 had us work from 8 times m minus 2 to 8m minus 16. And today we are looking at how to undo that process. So you now know how to take and do the distributive property and undo the distributive property. Two very, very important things in algebra. Greatest common factor and factor trees, useful, but not nearly as important as this. And finally, your homework is on page 167, 18 to 52, the evens.